Chapter 5.2, we're going to look at simplifying nth roots or radicals. So an expression involving a radical with index n is in simplest form when it has no more perfect nth powers other than 1. So letter A is an example or a review of simplifying square root of 24. So several ways that you can break down 24. Let's start with 8 times 3. And so the index is 2, so therefore I know I need a pair in order for it to come out, 2 of them. So 8 breaks down to 2 times 4 times 3. And then that also breaks down to 4 breaks down to 2 times 2. So therefore my pair is 2, and that comes out. And then you write whatever's left over, which is 2 times 3. So therefore it's 2 square root of 6. Now nth roots are the same. Now what's really important to note or look at is the index. That tells you how many of each that you need to take out. So letter B, let's start to break that down. 135, I know 5 goes into that for sure. So 5 goes into 135 27 times. Then we know that 27 breaks down to 9 times 3, or 9 breaks down to 3 times 3, and then there's another 3. So the cube root tells me that I need 3 of them in order for it to come out. So then I can write that on the outside as a single 3. Then this is cubed root of 5. Letter C, we have cubed root of 1,000. And so that breaks down to 10 times 10 times 10. Now I could break it down to 2s and 5s, but I already have 3 of what I need. So it comes out perfectly. So therefore, this answer is only 10. So try these examples here, D, E, and F. So trying this out, letter D, you know that 2 goes into it. So start with 2. 2 times 81 is 162. And then 81 breaks down to 9 times 9, and that breaks down to 4 3s. So 3 times 3 times 3. So the index 3 tells me I need 3 of them. So I circle 3 3s. That comes out as a single 3. And then you leave whatever else is inside. It's really important that you have the cube in the inside of that little V here. That needs to stay every single time, and then you multiply what's left, so that's 3 cubed root of 6. Letter E, I divided 4 first, so 4 goes into 256, 64 times. Then I hope seeing 64, you see that that is 4 times 4 times 4. And so therefore we have 4 4s inside the radical, and so the index is 4, so that tells me I need 4 of them to come out. So the index is 4, so I need a set of 4 to come out. 3 cubed root of negative 216. So hopefully when you see negative 216 in a cube, you see that that is negative 6 3 times. Okay, 6 to the third power is 216, and so the final answer is negative 6. Now let's do the same thing, but now we're going to add some variable expressions to it. So just variables are inside as well. So let's try 98k. So 2 goes into 98, so I'll start with that. So 2 and 2 times 4, and so 2 times 49 times k. 49 breaks down to 7 times 7, and because it's a square root, if there's nothing here, it's assumed it's a square root, then you circle a pair. So it's become 7 square root of 2k. Let's try letter B. We have cube root of 64y to the 6th. So we could do, there's 2 ways to do this. So I'll do it the long way first. So 64 we can break down to, hopefully you know that that's 4 times 4 times 4. Then I could write y 6 times. Looking at the index, how many do we need in order to circle it to come out? It's 3. The index is 3. So 3 4s, 3 y's, and 3 y's. So it's perfect. So each one comes out as a single piece. So 3 4s means it's just a 4. 3 y's means it's a y. 3 y's, it's also a y. Now to simplify that, then you just multiply. Y times y is y squared. Okay? Now another way to do it, let me rewrite this so we have room. So a second way to approach this problem, especially when our exponents get really large, so 64 we already know is 4 times 4 times 4. Now y to the 6, how many do we need to come out? We need 3. So if I write y to the third times y to the third, now I'm looking at my index, I want 3, and so if I write it this way, split up the 6 to 3 and 3, y to the third times y to the third is y to the 6th. So if you're looking at your index, and then try to break it down a little bit as to seeing, well, what can I do to make it similar to that, right? What can I multiply, meaning I add my exponents, will add to the 3, or break it down that way, then we could do it that way as well. So notice I have 3 4s, y cubed is 3y's, y cubed is also a 3y's, and you get the same answer, but it's a little shorter. So letter C, let's try that. 4th root of 128 n to the 8th. So I know 4 goes into it. 4 goes into 8 32 times. And then n to the 8, let's write that as, I need 4, so I can write as n to the 4th times n to the 4th. Because n to the 4th times n to the 4th is n to the 8th. So that helps me out. I don't have to write n 8 times. So that makes it a little nicer. So let's simplify this a little bit more. So 4 breaks down to 2 times 2. 32 is really 2 to the 5th, so I can write 2 5 times. And then I have n to the 4, n to the 4. So now I circle 4, because my index is 4. So 4 2's, n to the 4th, and n to the 4th. So this comes out as 2, and I have 2 n's that come out perfectly. Then I'm left with 4th root of 2 times 2 times 2. Simplify that all the way. So it's 2n squared. 4th root of 2 times 2 times 2 is 8. So try these 3 down here. So trying this out, letter D, you should have gotten 2r, 5th root of 7r squared. Letter E, you should have gotten 2m, cubed root of 3. Letter F, you get 3x cubed. Now looking here, it shouldn't be x squared. Now x to the 9th, remember you're adding the exponent, so it's x to the 3rd, x to the 3rd, x to the 3rd, because 3 plus 3 is 6, 6 plus 3 is 9, so that's why it is x to the 3rd.